Hello, welcome to my channel. In this video, I will be discussing resolution and resultant of vectors. What is resolution of vectors? Resolution of vectors is calculating the effect of a force along a particular direction. Let's say, for example, this is a body, okay, which is being pulled at an angle with a force of 9 Newton. With the force of 5 Newton, okay, at an angle 60 degree to the y-axis. If you want to get the resolution, this x-axis, if you want to get the resolution of this force along the y-axis, that is the effect of this force along the y-axis, the resolution will be equals to, along the y-axis will be equals to 5, okay, cos 60, okay. Now, that is the resolution of this force along the y-axis. Now, what is the effect of this force along the x-axis? If you want to get it, the way to do it is to find the angle between this place and this place, which is, since this is a right angle triangle, this will be 90 minus 60. Okay, since this is a right angle, this is this will be 90 minus 60, which is equals to 30. Okay, so the resolution of this force along the y-axis will be 5 cos 30. Okay, so this is what is called resolution of a vector. Since force is a vector quantity, it can be resolved along a particular direction, in this case the y-axis and the x-axis. It is very important to take note of this as you'll be using it in several calculations in mechanics and some other topics in physics. Let's look at another example. Let's say this is a slant surface, okay, and on this surface is placed a body whose weight is W, okay. We know that is the weight of an object is always towards the center of the earth, so it's act in a vertical direction, okay. If you are asked to calculate to get the resolution of this weight along this plane, what you need to do is to look at the angle of inclination of this surface here. Let's say the angle is theta, okay. With this acting directly in a vertical direction like this, it will form a right angle triangle here, right? Okay, and the angle in a triangle is equals to 180. If this is 90, then this will be 90 minus theta, okay, because this is 90 already, and we say the angle in a triangle is 180. So if you subtract the 90 that we have, it will be equals to 90. So the remaining 90 will be shared between this and this. And since we know that this one is theta, this one will be 90 minus theta. Okay. So if you want to get the resolution of this weight along the plane here, okay, If you resolve it, what it will give you is W cos 90 minus theta. Okay, so this is how to resolve this weight along the plane of the slant surface. Okay, now let's talk about the resultant of force of vectors. I'll be using the force as an example of the vector that we'll be talking about. Okay, now first of all, we'll talk about when there are two forces acting on a body. Okay, let's say this is a body and there is a force acting on this body like this in this direction. Let's call it force A. It can be any type of vector. It can be velocity. Okay, I'm just using force because it's easier to understand with force, but it's applicable to any form of vector quantity. Okay, so let's say this force is acting this way, and there's another force that is acting this way. Okay, the resultant of these two forces, let's call this force B. The resultant of these two forces is the additional effect, the summation effect of these two forces on this body is what is called the resultant of the vectors. The net effect that these two vectors, two forces will have on this body is the resultant of the force. Okay, and if you look at it very well, if you have a force pulling an object this way and another one pulling an object this way, this object will likely move in this direction, right? So this will be the resultant of the force. Okay. Now, how do you calculate the resultant of the force in this case? Usually to calculate resultant of a force when the body is being acted upon by two forces, you use the cosine rule. Okay, the cosine rule usually assume that this thing can be made up into a parallelogram like this. And assuming that the angle between the two forces, let's call it alpha, okay? The resultant of the force between them, let's call it C, okay? So this C can be calculated using the formula C squared is equals to A squared plus B squared minus 2AB cos alpha. This is the formula that is used to calculate the resultants of two vectors on a body. Okay, so with this, you will be able to calculate the magnitude of the resultant force. Now, to calculate the direction, you know that by the time you use this formula, you'll be able to get this value. Now, if you want to calculate the direction, let's say if you look at this parallelogram again, you know, since this side in the parallelogram, two opposing sides are usually equal, right? So this side is equal to this side, meaning that this space 2 will be B and this space 2 will be A. Okay? So let's call this angle that is facing A small a and the one that is facing B small b. Don't forget that this alpha is the total sum of small a plus small b. Okay? So let's say this is small b, okay, and let's say this angle is small c. If you want to calculate, don't forget that For vectors, is usually described in magnitude and direction. What this formula will do is to calculate the magnitude. Now, to calculate the direction, we need to either get this A, angle A or angle B, so that we can describe the direction of the resultant force, either relative to the force A or relative to force B. And for you to get that, what you need to do, what you need to use is the sine rule. Okay? Don't forget the sine rule as sine A over the side that is facing sine A over the side that is facing the angle, which is A here, okay, is equals to sine C. Of course, we know this angle C because, angle, adjacent angle in a parallelogram is complementary. This angle alpha plus C will be equals to 180. Alpha plus C will be equals to 180. The reason is that this is a straight line, okay? And the whole angle here is 180. So this angle will be equals to this angle, okay? So this angle C will be equals to 180 minus alpha. And since we will know alpha will be given in any question that we are doing, because that's the angle between the two vectors, okay, we can easily get the value of C, okay. So divided by the resultant of the vectors that we got, capital C, okay. So with this, we can get A will be equals to sine inverse of A sine C all over capital C. So this will give us the angle relative to a vector B. Okay, so this is how you calculate the resultant of vectors using the parallelogram rule. What will happen if the angle between the two forces is 90 degree? Because alpha will be equals to 0, right? So in that case, if we take this one to be A and this one to be B, okay, the resultants of the force will be C here. And if we complete it, it will look like a parallelogram too, right? And in this case, if we say C squared is equals to A squared plus B squared minus 2AB cos 90, cos 90 is equals to 0. So in the long run, this will not have effect on the formula, right? So what you later get is the resultant will be equals to A squared plus B squared square root. And once you get this C, you can calculate this angle. If you name it, let's say this opposing side is B and this opposing side is A. Let's say this angle is B, okay? You can calculate this angle by using tan theta, tan B is equals to opposite, which is B, all over adjacent, which is A. So B, meaning that this angle will be equals to tan inverse of B over A. So with this, you'll be able to get this angle. so that you can describe the resultant force both in magnitude, where you get here, and direction, where you get here, relative to vector A. Okay. Now, sometimes you may have a question in which you'll be given the force that will be acting on the body that will be more than two. Let's say, for example, this is a body, and let's draw our y-axis like this. Let's say there is a force here acting in this direction, acting at an angle A to the y-axis. Let's say this is another force B that is acting at angle B to the y-axis. Let's say this is another force here C that is acting at an angle C to the y-axis, and another force here acting, let's say it's D, acting at an angle D to the x-axis. If you want to calculate the resultants for this object, what you do is you need to resolve. Now, we'll go back to, if you recall, the first few slides that I have on resolution of vectors. This is where you apply it. You will resolve each of the force along both the y and the x-axis. Okay? Now, for y-axis, forces that will be acting on the y-axis, let's look at forces that will be acting on the y-axis. Let's start from A. Let's resolve it along the y-axis like this. This will be A cos A. We resolve this one. Now let's go to B. Let's resolve it along this y-axis plus, because it's in the positive direction, B cos B. Okay, plus, let's go to C. Now, you know, if you want to resolve this, you will not take it to this direction because it's a long way. What you do is you come towards this direction. And when you are coming towards this direction, don't forget that for this axis, this is the positive direction and this is negative direction. Meaning that when you are resolving this force along this direction, that will be negative y, right? That will be, in this case, it will be minus minus c, okay, cos the angle here, minus c cos c, okay, then d is the next, right? We know that this angle is d, right? This angle will be 90 minus d because this is a right angle, right? So the next one that we want to resolve now is this one. We will not bring it to this direction because it's far, okay? We will bring it to this direction, which is a negative direction of the y-axis. So it will be minus d cos 90 minus d, okay? So now we've resolved all these forces along the y-axis, right? The next thing now is along the x-axis. We do same for all of them. I'll be fast this time around. To resolve this one along this axis, this one will be 90 minus a. That will be a cos 90 minus a. Okay, that's in the positive direction. Now b, this one will have to come to this direction, which is negative direction of x. It will be minus b cos 90 minus b, right? Okay, that is b. Now for c, it will come to this direction. That will be minus c cos 90 minus c, right? Now d, it will come to this direction because it's closer to the positive side of the x. That will be plus d cos d. Okay, so now we've resolved all these uh, forces along the y, along the x axis. The next thing that we'll do now is to look at what is the result of all this resolution. If it is in the positive direction, we follow the positive direction for y. If it is in negative direction, we go this way. Okay, the same thing for the x. If it is in the positive direction, we'll go this way. If it is in negative direction, we'll go this way. So at the end of the day, you will get something that will look like this, either like this here, or like this here, or like this here, or like this here, depending on whether the summation of all the forces along the y-axis is negative or positive, and depending on whether the resolution of the forces along the x-axis is positive or negative. When you get this, you can then use it to calculate the resultants, which will give you the magnitude and the direction. This, I know this calculation is complex and it's really come out of the JAMB UTME exam, but I just want you to know how resolution of forces is applied in calculating the resultants in more than two forces. Okay. If you want me to make a special video on this, just comment in the comment section. I'll create a special video on calculating the resultant of vectors when it is more than two vectors. Okay. Now, having gone through the resolution of the forces and the resultant of the forces, let's go through some questions. Question number one. A vector of magnitude 10 Newton is acting at an angle 30 degree to the horizontal. What is the horizontal component of the vector? Let's say this is the horizontal, right? Let's say this is a floor, okay? And there is an object on it with a force acting, a force of 10 Newton acting at 30 degree to the horizontal. So what's the component? What's the horizontal component of the vector? The horizontal component will be the resolution of this vector along the horizontal plane, and that will be equals to what? 10 cos theta, which is equals to 30, right? So that will be 10 cos 30. Okay, so if you press your calculator, you can get the answer there. Now, the vector of magnitude 10 Newton is acting at an angle of 30 degrees to the horizontal. What is the vertical component of the vector? I think this is similar to what we saw in the last slide. Let's say, let's say this is the surface. Let's say this is the surface, and there is a body here with the force acting 10 Newton force acting 30 degree to the horizontal. Right? They said the vertical component of the vector. So it means we'll resolve it along this y-axis, and this will be equals to 90 minus 30, which is equals to 60. Okay, but it will interest you to know that 10 cos 90 minus 30 is the same thing as 10 sine 30. Press it in your calculator, you see that you get the same thing. What I want you to take note of is that if you have a right angle like this, okay, and you have this angle theta, okay, usually cos 90 minus theta is equals to sine theta. This is true, okay? Just check it. It's correct. So instead of using cos 90 minus 30, you can just say sine 30. You'll get the same thing. I'll leave the remaining question for you to solve. Please kindly subscribe to my channel, like this video, and share, okay? And click the alert bell. Click the bell sign for you to be alerted when I upload new videos, okay? So you can go through this question. Thank you for listening. Don't forget to like, share, and subscribe to my channel. If you want me to make video on a particular topic, you can write in the comment section below. I'll be very glad and willing to make video that will be very explanatory. Thank you for listening. Bye bye.